Yeah. So coming back to the sequence-backed reactors, which are mainly used for this sewage analysis process. Mainly, this is used as a fill and draw activated sludge system, mainly used for the water treatment, and which operates in the batch mode, treating the wastewater in a single time through sequential cycles. And mainly, it consists of a reactor basin where a single unit it serves as a single unit for all the treatment process, and it has a radiation system by providing the fine bubble diffusers or the mechanical aerators, which provide the oxygen for the biological treatment. And it has a mixing system where these agitated mix the suspended solids, and in order to enhance the biological activity, and proper agitation should be a good sign for the good microbial degradation. And decanter system where the floating or the fixed decanter removes the treated effluent without disturbing the sludge which is settled at the bottom. And the control system is always there in order to control the whole system. And the working principle is that first the influent place where the wastewater enters the reactor and getting mixed properly, and in the second stage where it reacts, that is the aeration phase where the proper aeration is present provided in order to have a biological degradation of organic matter and the nutrient removal. And step 3, the settlement of the sludge, where the sedimentation process occurs, where the aeration is stopped and allowing the solids to settle down by the help of gravity. And the superlatent will be flowed at the top of the this thing tank. And the decant, where the effluent, the decanting system removes the treated water without disturbing the settled sludge. And sludge washing and reset phase, where the excess sludge is removed from the bottom of the tank and then prepared for the next cycle. And each cycle lasts for about 4 to 8 hours depending upon the wastewater characteristics. And the design parameters will be like this: HRT will be around from 4 to 24 hours, solid retention time for 10 40 days, and then cycle time is for 8 hours, and then organic loading rate about 1.2 kg BOD for 5 days, meter cube per day. And then aeration is like diffused or mix, and air quality and all effluent quality will be less than 10 mg per liter. And main advantages of this process is it's because of its compact design, cost effectiveness, efficient organic and nutrient removal, flexible operation, and automated control. And design disadvantages are mainly like it mainly requires the skill operation, batch mode limitation, foaming, sludge bulking issues, and then higher energy demand and all. But mainly these applications of these sludge blanket is mainly used for the industrial, municipal, decentralized treatment systems, and the nutrient removal systems. So coming to the trickling filters, where it is well established, and biological water treatment, where it utilizes the fixed bed for the media to in order to remove the organic matter. And mainly this trickling filters has the process of biofilm formation, organic matter removal, and slowing. And it has a filter media distribution system, under drain system. And mainly advantages for its simple operation, low energy consumption, and its robustness. And disadvantages are odor potential, fly nuisance, and the space requirements and potential for clogging. And the main advantages of these trickling filters are these trickling filters are mainly suitable for the domestic and some industrial wastewater treatment purposes, and they are often used in small and medium-sized communities. And as we see, these are the trickling filters mainly used for the design of mainly used in industries. And coming to the rotating biological contractors, these are the valuable technology in wastewater treatment, offering a unique approach for the biological pollutant control. And it mainly has a fixed film biological process, and it provides the aerobic treatment. It has the disc rotation, biofilm development, aeration and flowing and clarification. Mainly, it has the simple in operation, very low in energy consumption, robustness, good for smaller systems and all, very sensitive to the climate. It is also a main disadvantage. Its maintenance is very difficult, and also it has main space requirements as well. These are mainly required and mainly effective for the removing of organic matter, and also can achieve the nitrification process. So coming to the advanced or tertiary treatment, where the nitrogen removal takes place by nitrification and the denitrification process and nanomox process. And coming to the phosphorus removal by the biological and chemical removal process. And coming to the membrane bioreactors, which are significant advancement in the wastewater treatment technologies, and they combine with the membrane filtration, result in high quality effluent and a smaller footprint compared to the conventional systems. And these integrate this membranes filtration process, such as this microfiltration, ultrafiltration, and biological treatment process typically an activated sludge system. This is a combination of both actually. So it allows the separation of the solids and also the liquids by using the membranes, which helps in eliminating the need for the traditional secondary clarifiers as well. So these basically work in a process where the wastewater enters the reactor, which consists of microorganisms which play a crucial role in breaking down the organic pollutants, which is just similar to that of activated ASP. And instead of settling the solids in a clarifier, the mixture is filtered through the membranes, which retain the solids and bacteria, producing a clear, high quality effluent. And these membrane act as a very fine filter, preventing the suspended solids, bacteria, and viruses from passing through the filter. Mainly advantages for its high quality effluent, smaller footprint, high biomass concentration, improved nutrient removal, and disadvantages include the membrane falling, energy consumption, and high capital and operational cost, and mainly suitable for the application requiring high quality effluents such as water use and sensitive environmental discharges. And also they are used in locations where space is limited. And as we look into the picture, here is the membranes. What we see, there are different membranes here, and the water is passed through the force by a pressure gauge, and by which we will be attaining the clear and more fine water. And coming to the advanced oxidation process, this is another process apart from the membrane filtration. And these AOPs are generally a chemical treatment procedure where it is designed in order to remove the organics and from the water and the wastewater by the process of oxidation through several reactions with that of OH ions and other strong oxidizing species. The main principles behind this process is the generation of the reactive species, where these AOPs rely on the in situ generation of reactive species, primarily these OH ions. And these OH ions are particularly powerful antioxidants that can rapidly and non-selectively degrade a wide range of pollutants. And these are used for the oxidation of contaminants by using of microorganisms, and by using this OH and inorganic ions particularly. Alright, so the usage of these reactive species oxidizing the organic contaminants and then break down into their simple and less harmful substances, which often lead to the complete mineralization, that is conversion to CO2, H2O, and inorganic ions. Alright, so the common AOP technologies are the ozonation, and ozone is a strong oxidant that can directly react with the pollutants or decompose to form the hydroxyl radicals, and H2O2, which is the hydrogen peroxide, which can be used alone or in a combination with UV light or catalysis in order to generate the OH ions. So coming to the UV process, all right, ultraviolet or hydrogen production, hydrogen peroxide. So this combination of both UV light and hydrogen peroxide enhance the production of radicals, and this is mainly by the photophantom reagent, which generates the radicals. And by using this photon phantom process, which utilizes the light in order to enhance the phantom reaction. So it is a combination of both in order to degrade the organic contaminant. So the photolysis, if you look into the photolysis, mainly the semiconductor photolysis such as the titanium oxide, which are mainly used and activated by the UV light by generating this OH ions. And there's mainly applications for the removal of the emerging contaminants, treatment of industrial wastewater, the disinfection process, drinking water treatment, and all this. So other advantages include that it is effective in removal of recalcitrant pollutants, and then high oxidation potential it has, and it has minimal sludge production. And the main disadvantages is a high energy consumption, capital cost, and byproduct formation. and the considerations can be by doing the process optimization. That is, the factors such as pH, temperature, and the contaminant concentration must be optimized for efficient AOP operation. All right. And then next one is the consideration. What we have to do is the cost effectiveness, which can be relatively expensive, so that so their use is often reserved for treating the specific pollutants or achieving high quality effluent only. So coming to the disinfection process, where disinfections are the main crucial step in wastewater treatment. Mainly it is designed to inactivate or kill the pathogenic microorganisms such as the bacteria, viruses, protozoa before their treated effluent is discharged into the environment, or it can be used as other wastewater reuse can be done by this process. So coming to the chlorination process, where the main mechanisms include the chlorine, which is in various forms, that is either by liquid, gas, or in the form of sodium hypochlorite or calcium hypochlorite, and this basically reacts with the water in order to form the hypochlorous acid, which is a powerful oxidizing agent that disrupts the microbial cell membranes and thereby inactivating their enzymes. And the main advantages of this chlorination process is that it is really inexpensive, effective against a wide range of pathogens, and this residual chlorine also provides this ongoing disinfection process. And the disadvantages can be like by formation of disinfection byproducts like trihalomethanes, which are potentially carcinogenic, and requires careful control to avoid excessive chlorine levels. So there should be something like control also. So they, as we look into the picture here, so there is a chlorine injector where the water is like stored and then pumped into the storage tank. In between there will be a chlorine injector uh, kind of thing, where the chlorine can be injected, and that is how the water can be disinfected, and then we can also the filter the sediments present near to the tap, and then we can obtain the clear water. So excess can always have a potential probability of having a carcinogenic properties, and so there should not be like excess chlorine levels in the water. So coming to the ultraviolet disinfection, and this is another kind of disinfection where the UV light, specifically the UVC, that is which ranges from 200 to 280 nanometers, which damages the DNA of the microorganisms, preventing them to replicate. All right. So coming into the disadvantages of this UV disinfection is that it is effective against wide range of pathogens, including the chlorine-resistant organisms like Christoporidium and Giardia, and no DBPs are formed, and then relatively low in maintenance, and the disadvantages are requires clear water. Okay, so preliminary and primary treatment should be done in order to go for the disinfectant process. So the turbidity, the lesser the turbidity, more the treatment efficiency by the UV process. For the effective penetration of mainly for the UV light for its effective penetration into it, and no residual disinfection, and can be energy intensive. So coming to the ozonation process, where the ozone is a strong oxidant that disrupts the microbial cell membranes and also inactivates the enzymes. And the disadvantages are like it is highly effective against a wide range of pathogens, including viruses and protozoa, and it also can remove some organic contaminants. And the disadvantages include the high capital cost and operating cost, no residual disinfection, and ozone is unstable and must be generated on site. So coming to the uh, Peracetic acid. So this is again another oxidizing agent, which disturbs the microbial cell membranes, and it is highly effective against the wide range of pathogens, and it also like decomposes to environmental friendly byproducts, that is acetic acid, water, and oxygen, and can be used in wide range of pH and temperature oriented waters. And disadvantages are mainly relatively expensive and can be corrosive, and no residual disinfection. So coming to the next one, which is the chlorine dioxide. So this is another strong oxidant that disturbs the microbial cell membrane. It is mainly effective against the wide range of pathogens and does not form THMs, and also effective at a wide range pH range. And the disadvantages are it must be on-site only due to its instability and can form chloride and chloride byproducts, which are again not non-healthy. And the main key considerations we have to look into this process is mainly the pathogen inactivation. So whichever disinfection process the water might undergo, the main primary goal is to achieve the sufficient level of pathogen inactivation in order to meet the regulatory compliance. And then disinfection byproducts, that is mainly by deformation of DBPs, that is the disinfection byproducts, is crucial for protecting the public health. So DBPs might either be carcinogenic or health free also, but we have to take care like minimal injection of chlorine or minimal oxidation process only should occur. And coming to the residual disinfection process, where some disinfection methods provide the residual disinfection, which can be beneficial for preventing growth of microorganisms in the distribution systems. Another consideration is mainly the cost and the energy consumption. And since this disinfection method should be considerable based on its cost, energy consumption, and uh, the purpose of the treatment and all, and also the environmental impact. Also, the environmental impact of this disinfection byproducts and residual disinfection should be evaluated. And regulations, local regulations dictate the required amount of disinfection process. And now we look into the solid waste disposal. So till now we have seen how the sewage will be treated, what will be the analysis and all, and how the disinfection process and all. So overall, we have an idea of what are the water treatment technologies available. Now we will be again look into the solid waste disposal. So if we look into the solid waste disposal, it is a main crucial aspect for the water and wastewater treatment, as these processes generate various solid byproducts that need for the proper management. These solids might include from screenings, grit, primary and secondary sludge, and biosolids. So the interconnectedness of solid waste management and the water quality is a crucial environmental issue, and this improper solid waste disposal directly or indirectly also contaminates the water resources, posing significant risk to the ecosystem and the human health. So the disposal methods must comply with that of environmental regulations in order to prevent the pollution and enhance the resource recovery. So if into the main sources of solid waste in the water and wastewater treatment, that is the screenings and grit, where screenings might be coarse solids such as plastic, logs, rags, sand removed in the preliminary stage treatment and all. And then primary sludge mainly is the settled inorganic and organic solids from the sedimentation tanks. Secondary sludge mainly the biomass generated from the biological treatment process such as ASS and the trickling filters, and the tertiary waste solids, which includes the residuals from the advanced treatment process like filtration and chemical precipitation. So coming to the main sources again. So if you look into the detail of this, main sources of this solid waste mainly comes from the municipal solid waste, all right, which is mainly from the household, commercial establishments and institutions, which mainly includes the paper and the cardboard, plastics, food waste, textiles, glass, metals, yard waste, etc. Which these mainly enters through the improper disposal into the sewers, and littering and stormwater runoff and combined sewer overflows and all, and then industrial waste. So basically, these are generated by manufacturing, processing, and other industrial activities, and characteristics may widely vary from depending upon the industries. Whether if it is a chemical waste, that is sludge and residues will come out, and heavy metals, oils, and solvents. Industrial waste can contaminate water through discharge of untreated wastewater, leaching from the industrial waste disposal sites, and might be because of the accidental spills as well. So coming to the agricultural waste, where it is mainly derived from the farming and the livestock operations, which mainly includes this animal manure, crop residues, agricultural waste impacts water mainly through the nutrient loading that is ultimately causing the eutrophication in the water, pathogen contamination, pesticides, and herbicide pollution as well. So coming to the construction and demolition waste, where it is mainly generated from the construction, renovation, and demolition activities, which mainly include the concrete, rubble, wood, metals, and asbestos. And these can CD waste can be pollute water through mainly sediment runoff, leaching of heavy metals, and physical debris entering the waterways. So coming to the characteristics of these solid waste relevant to the water systems. So the main composition of this solid waste might determine the pollutant potential pollutants. That is, this organic waste contributes to oxygen depletion in water. Inorganic waste can persist and accumulate. And leachability, the main availability the ability of the pollutants in order to dissolve and be carried by the water. And this is the leachate. And hazardous waste also, and some industrial waste also have this high leachability. And the smaller the particles, they are called microplastics, which are easily transported and ingested by the aquatic organisms. And larger debris can be causing the physical obstructions particularly. And biodegradability. So biodegradable waste breaks down naturally, but excessive amounts can deplete the oxygen levels in the water. And non-biodegradable waste such as plastics persist and accumulates for a longer time. And the toxicity of the solid waste, some solid waste contains the toxic substances that can harm the aquatic life and human health. And the solid waste significantly impacts the various stages of water and wastewater treatment process, which leads to the operational challenges and reduced efficiency. And first one is the primary treatment, where the use of screening and grit removal occurs, and which mainly causes the blockages and the reduced efficiency. And grit removal can also hamper the excessive solid waste. And secondary treatment, which includes the sedimentation process, where the sludge contamination occurs. And in this basically the non-biodegradable solid waste mixes with that of primary sludge, making it difficult to treat and dispose. And this mainly affects the quality of the biosolids produced. So coming to the reduced settling, the lightweight solid waste, that is particularly like plastics, which mainly interfere with the settling of the heavier solids. And this also reduces the effectiveness of the sedimentation and increases the load on the secondary treatment as well. So coming to the tertiary treatment, which is the biological treatment, and which disrupts the microbial activity, where the so toxic chemicals from the solid waste can also inhibit or kill the microorganisms, which are mainly essential for the biological treatment. And this also reduces the efficiency of the organic matter removal. So there are something like biological filters as well, and which can be clogged due to this. So clogging of the biological filters, where the fine solid waste can clog biological filters and aeration systems, which are ultimately reducing their performance. And increased sludge production, where undigested solid waste increases the volume of the secondary sludge. So coming to the tertiary treatment, where advanced filtration and disinfection takes place, where the filter clogging majorly occurs through this process. And fine particles, microparticles, and can actually clog the advanced filters. Alright, mainly if you say this a membrane filtration unit or UV or whatever, and this mainly clog the advanced filters, requiring the frequent backwashing and maintenance. And reduced disinfection and effectiveness, where the solid particles can shield the pathogens from the disinfectants. All right. So these solid particles, if not removed, the disinfectants cannot directly act upon the microorganisms. So mainly the disinfectants such as the chlorine or the UV light, which reduces the disinfection efficiency. And coming to the microplastic presence, and the tertiary treatment is needed in order to try and remove these microplastics. And if the previous stages are overwhelmed, then the tertiary stages will also struggle to remove the excessive microplastics. Coming to the sludge treatment and disposal, where increased sludge volume actually requires more extensive treatment and disposal, contamination of the biosolids with heavy metals and other pollutants, limiting their beneficial reuse, and increased disposal cost, and which the sludge disposal mainly in the form of landfilling or incineration, and contaminated sludge increases the main disposal cost as well. And challenges in the waste disposal would be the solid waste disposal is the increasing waste generation, that is mainly due to the exponential growth in the municipal solid waste and hazardous waste, and landfill limitations, mainly the land scarcity, leachate, contamination, and greenhouse gas emissions, and environmental pollutions, mainly the air, water, and soil contamination from the improper disposal, and recycling and resource recovery through the contaminated recyclable reuse. The quality and marketability of the recycled materials can be increased, and by the public health risk, mainly the disease vectors. All right, so the disease vectors, exposure to toxin, and community health impacts, and economic burden, where high cost of waste collection, transportation, and treatment also causes high economic burden, and social equity because of the disappropriation disproportionate impact of marginalized community also affects the social equity. And coming to the solid waste disposal technologies, basically the traditionally we follow the disposal technologies of solid waste management for decades, though they are increasingly being challenged by the environmental concerns and the growing volume of the waste. So we generally do the traditional landfilling technology is basically and globally used, and it is a very common method. And this mainly involves the burying of waste in the designated areas, where the modern landfills are engineered in order to minimize the environmental impact. So initially there was just excavation of the land and then dumping everything there and then closing and all. So those that thing is like more very disease infections and all that, having a huge impact on the environment, where the modern landfills are actually engineered in order to minimize this environmental impacts. So as we see in this picture, so there is a liner present for this landfill. So this liner, either it could be by concrete or it could be through this PVC and all. So there is a thick lining which does not allow the solid waste getting to the groundwater table or the leachate of the solid waste entering into the groundwater. So that is how the liner helps, and there is a cap cover also where through the wind or air, there will be no dispersion of the solid waste, and it is like more compacted in size as well, and the leachate and the drainage collection also is present, where that can be drawn as and when required, and that will be collected and treated further. And the wells also, the wells present also are not at all affected because of this advanced modern landfill technologies. And the main key features, if we look into it, are the liner system, which prevent the leachate from the from contaminating the groundwater, and leachate collection and the treatment, where mainly collects and treats the contaminated liquid, and the gas collection mainly captures the methane gas for energy production or for flaring. So as and when there is more amount of land filling, there is more amount of methane production, and this methane can be used as energy, like for the gas purpose, that can be used for cooking and all. So basically this land filling is done by some of the industries, particularly like for utilizing this methane gas as a part of cooking and all. And coming to this compaction and covering, this reduces the volume and prevents the odors and fly nuances and all. And main challenges are the land scarcity, especially in the urban areas, and the leachate contamination of groundwater and surface water, and methane emissions, which cannot be controlled and contributing to overall the climate change. Long-term monitoring and maintenance also is required. So coming to the disposal technologies, apart from the landfilling, there is incineration process, that is waste to energy, where during this incineration process, the waste is burnt at high temperatures, reducing its volume significantly. And modern incinerators offer recover the energy in the form of heat or electricity. And key features. So basically this. Hyderabad Municipal Waste Corporation. So what they do is they collect the waste and dump in a dump yard. And there we have this incineration facilities where the whole litter or whole solid waste is dispersed into it, and that is how more amount of electricity and heat can be generated and can be utilized for several other purposes. So that is how the modern incinerators work. And the main key features is the high temperature combustion in order to destroy the pathogens and reduce the volume. And air pollution control systems are also there in order to minimize the emissions. So energy recovery through steam and electricity generation occurs. And ash is also collected and properly disposed, otherwise it will be dispersed into the atmosphere again through inhalation, causes several problems and respiratory problems. And the main challenges included for this incineration process is the air pollution, including the emissions of dioxins and fumes, and ash disposal, and which mainly contain this heavy metals, and high capital and operating cost as well, and public opposition due to the perceived health risk. So coming to the incinerators into detail, it is generally a thermal waste treatment process which includes the combination of combustion of organics in waste materials, and these waste materials in turn convert the waste into ash, flue gas, and heat, and it is mainly found by the inorganic constituents of the waste, and that may take from the form of solid cakes or suspended particulates matter carried by the flue gas. And the flue gas must be filtered particularly by the using of scrubbers and all, in order to clean the gaseous and particulate pollution before they get discharged into the atmosphere. And particularly in some cases, the heat generated by incineration is also used to generate the electric power as well. So coming to the next one, which is the incineration advantages, where treatment of certain wastewater, certain waste types in which areas, particularly clinical waste and certain hazardous waste, where pathogens and toxins can only be destroyed by high temperatures. Alright, some examples of these chemical multi-product plants with diverse toxic or very toxic wastewater streams or clinical waste, which cannot be routed to the conventional wastewater treatment. So that is how it is been done. And in short, it is actually the process. The incineration is the process of burning solid, liquid, or gaseous combustible waste at specified rates. So when the operated efficiently in a properly designed incinerator, the result should be a pollutant-free emission of the products of combustion. Alright. So now if we see that the waste can be classified into different types. So type O to type 6. So as per 22A. So let us see. So the type O waste. So the type O waste is defined as a trash, which is a mixture of highly combustible waste such as paper, cardboard, cartons, and wooden boxes and combustible floor sweepings, and from commercial and industrial activities particularly. These mixture contain about 10% of the weight of plastic bags, coated paper, laminated paper, treated corrugated cardboard, oily rags, plastic and rubber cans. This type of mainly waste mainly consists of 10% of moisture and 5% of incombustible solids. And coming to the type 1 waste, which is mainly defined as a rubbish, and it is mainly a mixture of combustible waste such as paper, cardboard, cartoons, wood and scrap foliage, and combustion floor, and sweepings from domestic, commercial, and industrial activities. And this type 1 weight mainly consists of contains about 20% by weight of the restaurant waste, but contains little or no treated paper, plastics, or rubber waste. And coming to the type 2 waste, which is defined as refuse. Okay, consists of approximately even mixture of rubbish and garbage by weight. So this type of waste is common to apartment and residential occupancy because it consists about 50% of moisture, 7% of incombustible solids, and has a heating value of 2390 kilocalories per kg as fixed. So coming to the type 3 waste, which is mainly defined as a garbage consisting of animal and the vegetable waste from the restaurants, cafeterias, hotels, hospitals, markets, and installations. And this type of waste mainly contains about 70% of moisture, 50% of insoluble solids, and heating value of 1390 kilocalories per kg as final. So type 4. So if you look into the type 4, it is mainly the human and animal remains consisting of carcasses, organs, and some organic waste hospitals, laboratories, animal pounds, and similar sources containing about 85% of moisture and 5% incombustible solids, and having the treating value of 555 kilocalories per kg as fixed. So coming to the various incineration techniques. So now that we know that there are five types, that is the type 0, type 1, type 2, type 3, type 4 waste, and we will be now looking into the various incineration techniques. The first one is the fluidized bed incineration process, where this can be used as a bed of inert materials, preferably sand, which are then suspended by air or glass flow. So this waste is fed into the system where it is combusted at temperatures between 750 to 950 degrees centigrade. And the main advantages of this process is the high thermal efficiency and uniform heat distribution, soluble for wet and low calorific sludge, low NOx emissions and better pollutant control. And the disadvantages mainly include the high inertial capital and operational cost, requires pre-treatment particularly for the sludge. And coming to the next one, which is the multiple hearth furnace, where it where a series of tracked circular hearths where waste moves downward as it is heated and combusted. So the applications included roasting ores and reducing metal oxides, producing the activated carbon, calcining chemicals and minerals, incinerating sludge of sewage sludge and other waste materials, and treating the electronic scrap. All right. So the main temperatures ranges from 800 to 980 degrees centigrade. Mhm. Then advantages are mainly like in order to handle a wide range of waste moisture content, relatively lower maintenance requirements, and the disadvantages are mainly the lower cost, lower energy recovery efficiency compared to the modern systems, and higher operational cost due to complex mechanical components. So as we look into the picture here, these are the multiple earth finance where the wastewater is passed through it, and from there it gets filter, and then reaches the output. So coming to the rotary kiln incineration process, where where the rotating cylindrical drum where waste is fed and incinerated under controlled temperatures between 850 to 1200 degrees centigrade, and the rotary kiln incinerator breakdowns and decomposes material into the simple compounds via complete combustion, converting the waste into an ash residue and thereby significantly reducing the waste volume. All right. So this is around 815 degrees centigrade to 1200 degrees centigrade. The waste is fed and incinerated at this temperature, and in this case, the it breaks down and decomposes in material into the simple compounds, and converting this waste into an ash residue and thereby significantly reducing the waste volume. And it also handles a variety of solids and liquid waste suitable for the hazardous and non-hazardous sludge, high flexibility in operating conditions, and the main disadvantages are high energy consumption, requires advanced air pollution and control systems. So here in this picture, what we see is the rotary clean incineration process, where there is a clean here where the waste is inputted and the gas is sent inside, and at a higher degree of temperature, the breakdown occurs of the organic matter and simple compounds come out, and the ash-based residue is obtained. So coming to the electric arc plasma incineration process. So using a plasma torch to generate extremely high temperature up to 5000 degrees centigrade. So or even more up to like around 14,000 degrees centigrade also. It will be going up based on the usage of the product. So during this high temperature, it mainly breaks down the waste into basic molecular components. And in this process, an electric arc gasifier passes a very high voltage electric current through two electrodes, creating an arc between them. Alright. So as we see here, there is an anode, there is a cathode. Alright. So these two arcs, what they do is they electric arc. These two electrodes, what they do, they create a high pressure, right? A high voltage electric current is passed through this anode and cathode, and by which there is an arc between these two electrodes, and which is under high pressure, then passes the electric arc into a sealed container of the waste material. So wherever the waste is there, this anode and cathode with high electricity, with high electric current, they passed through in the position of arc between them, and the gas is also sent. All right, the waste and the glass or the inert gas and everything is sent inside under high pressure, and then passes through the electric arc into the sealed container, and which is called as a plasma converter of the waste materials. The main advantages of this process is to have the complete destruction of organic and inorganic materials. It produces syngas and other vertified slag, and minimal pollutant emissions are also there. And coming to the disadvantages, higher operational and maintenance cost, of course, and then require specialized infrastructure and the trained professional, right? And then coming to the gasification and the pyrolysis process, where these are also the advanced thermal process where the waste is heated in a low oxygen, that is pyrolysis process, or the controlled oxygen, that is the gasification environment. All right. So low oxygen is the pyrolysis process, controlled oxygen under gasification process. This pyrolysis mainly leads to the production of solid, liquid, and gaseous products, whereas the gasification primarily producing syngas, and these both processes can convert the organic materials into valuable products and can be used for energy production. This pyrolysis mainly occurs between 300 to 700 degrees centigrade, while the gasification occurs around 800 to 1200 degrees centigrade. So the main advantages is that it produces syngas, which is useful for other processes, bio oil and char for energy recovery, and lower environmental impact compared to the direct incineration, and reduces the landfill dependency as well. So the disadvantages include requires significant energy impact input, and complex process control and monitoring systems are required for this process. So coming to the open dumping and composition. All right. So coming to the compost. Coming to the open dumping, where this is uncontrolled disposal of waste in open areas, and it is highly detrimental in the environment and public health. And unfortunately, it is still very common in the developing nations. And the main challenges are the contamination of soil, water, and air, spread of disease vectors like rats and flies, odors and aesthetic degradation, increased risk of fires, and public health hazards. And as we see here in the picture, most of the rack pickers spend their time there in the landfills, owing their life into risk. All right. So next, let's go into the composting, where it is a traditional large-scale process. So during this composting process, there is a biological decomposition of organic waste under the controlled conditions, and it also produces a nutrient-rich compost that can be used as a soil amendment. The main key feature is that aerobic or anaerobic process, either it could be aerobic or anaerobic process, and the temperature and the moisture control, turning or aeration to promote the decomposition process. So the main challenges of this composting is to require the source separated organic waste. Odors can be a problem if not managed properly. Contamination with non-compostable materials, and large areas of land are modified for large scale composting, right? Big lands for big area for big installation and or land composting and all. So give me a second. So coming to the wastewater, so which is mainly like water being the predominant resource for the environment. So, water being the predominant resource for the environment, agriculture, and industrial sectors, which has raised concern across the globe for its water scarcity, wastewater disposal, and which urges the need for the efficient management of the water resources. It is mainly the process that safeguards the public health and protects our environment, ensuring it's clean and safe for reuse or release. It is the process of basically removing of pollutants and contaminants from the wastewater, which is generated by the residential, commercial, and industrial activity within the community. So, this wastewater, if left untreated, can pose a serious risk to the human health, aquatic ecosystem, and the overall environment as a whole. So, basically, this wastewater, if it is left untreated, mainly it carries the pathogens, organic matter, nutrients, and other harmful substances that can contaminate the water sources, spread diseases, and disturb the natural ecosystem. And therefore, the effective water treatment or wastewater treatment is a fundamental step to public health and environmental sustainability. So, basically, let us look into this characterization of wastewater and degree of treatment. So, characterization of wastewater, which mainly involves the analyzing its physical, chemical, and biological properties in order to understand its composition and also to understand its potential impact on the environment and public health. So, this characterization is mainly crucial for determining the appropriate degree of treatment required before the wastewater can be safely discharged or reused. All right. So if we look into the physical characteristics, the total solids. So total solids are nothing but the total amount of solid material present in the wastewater, which includes the dissolved and the suspended solids, which can be done by the gravimetric method. And coming to the suspended solids, so these are the portion of the total solids that can be retained by a filter, by using a filter. All right. So total suspended solids may cause this turbidity and reduce the light penetration in the water bodies and settle to form sludge. Okay, so high TSS again affects the aquatic life because of its turbidity and because of not letting the sunlight penetrating down into the water, and oxygen levels also get depleted because of this. And it can also be measured by gravimetric method. And coming to the total dissolved solids, that is a portion of the total solids that passes through the filter. And this is also like TDS can affect the taste and suitability of the water for various uses, either drinking purpose, industry purpose, or any other purposes. And measurement is again by gravimetric method. So coming to the turbidity, turbidity is the main measurement of measuring the cloudiness or haziness of the water due to the presence of suspended particles. And the main measurement method is the nephelometric turbidity units, that is NTU. So turbidity is measured by NTU units, and by using a turbidimeter. And the color is an indicative on the presence of certain industrial waste or decaying organic matter, which is mainly used by the visual comparison with the color standards or spectrophotometry. And odor which can indicate the presence of decomposing organic matters, which is sulfides and other specific pollutants, which causes a foul smell. And by sensory analysis only it can be measured. And the temperature mainly affects the biological activity and the solubility of gases in the water, which can be mainly measured by the thermometer or the thermocouple probe. And the chemical characteristics, so coming to the chemical characteristics, where pH plays a major role, and it is a measure of acidity and alkalinity of the wastewater, and it can be mainly measured by the pH meter or the pH probe. And coming to the BOD is the biological oxygen demand, and it measures the amount of dissolved oxygen consumed by the microorganisms during the aerobic decomposition of organic matter in a specified time period. And that is for 5 days. The bottles will be filled with water and chemicals, and it will be sealed and kept in refrigerated at 20 degrees C and cannot be disturbed. And after the fifth day, the BOD levels will be indicated with that of titration method. And high BOD indicates the high level of biodegradable organic pollution, and measurement by 5-day BOD test. And COD is the amount of oxygen required to chemically oxidize all the organic and inorganic substances in the wastewater. And COD is generally higher than BOD, as it measures the biodegradable organic matter as well. So the main method for this measuring COD is the dichromate digestion and titration method. And coming to the nutrients, where the total nitrogen represents the organic and inorganic nitrogen compounds. Measurement through Geldal method for organic nitrogen. And total phosphorus, which indicates the concentration of all phosphorus forms. And the colorimetric method, after the digestion, this method is used. And for the heavy metals, toxic metals like lead, mercury, cadmium, chromium, etc., which can accumulate in the food chain and pose the health risk for a long period of time. And this can be measured by ICP-MS and EAAS. And coming to the organic compounds, where a wide range of synthetic and the natural organic compounds which includes the pesticides, solvents, pharmaceuticals, personal care products, etc. And some of these are actually toxic and persistent to the environment. So this can be measured by using this EAA, that is atomic absorption spectrophotometry. All right. So coming to the grease, oil and grease, which can form, which can form a layer on the water surface, hindering the oxygen transfer and harming the aquatic life. So basically, this can be measured by the gravimetric method. All right, and which extract the oil and grease using solvents, evaporating the solvent, and weigh the residue as well. So either by leaving using the laboratory equipment like Soxlet extractor and analytical balance as well. So coming to the biological characteristics, where pathogens are the disease-causing microorganisms which might be bacteria, virus, protozoa, and helminths. This presence indicates a high risk of waterborne diseases, and the measurements method, that is by using this PCR for specific pathogens. Indicator organisms. Organisms like fecal coliforms, that is Escherichia coli, are mainly used to indicate the potential presence of the fecal contamination and pathogens. And measurement method, most probable number of the membrane filtration should be done. Alright, for this kind of things. And then specific microorganisms. So analysis for specific type of bacteria or other microorganisms may be necessary depending upon the source of wastewater. All right. Next one, the degree of treatment. So there are different degrees of treatment depending upon the factors and the source of water, receiving of water body, the source of water, mainly the domestic industrial agricultural combination can have a characteristic pollutant profile will be present. And coming to the receiving the water body, that is the type and sensitivity of the water body when the where the treated effluent will be discharged. All right. And strict standards and are required for sensitive ecosystems or drinking water sources. So coming to the regulation and standards, where the local, regional, and the national regulations set limits for the concentration of various pollutants in the treated effluent, and there is an intended reuse of wastewater. If the wastewater is treated appropriately, is it intended for its reuse and for the different purposes like irrigation, industrial processes for the mainly for the coolants and all, and non-potable urban uses, etc. And this treatment requirements will be determined by the specific reuse application. So coming to the wastewater treatment. So now that we know the characterization of water and all, now we will be deeply looking into the wastewater treatment technologies. So first wastewater is collected, odor control, screening, primary treatment, secondary treatment, tertiary treatment, disinfection, sludge treatment. All these are also the part of wastewater treatment. All right. So let us look into this wastewater treatment technologies, where everywhere, like where either it is sewage, either it is like wastewater or normal different wastewater treatment technologies. The typically includes this treatment mainly includes the preliminary treatment, followed by the primary treatment, then followed by the secondary treatment, tertiary treatment, and sludge treatment. So coming to the preliminary treatment, where it removes the large debris and heavy solids from the incoming water. All right. So in this preliminary treatment, let us look into the screening level, where this involves the use of bar screen or mesh screens in order to capture large objects such as sticks, leaves, rags, logs, plastics, etc. that obstruct the flow of water, and the collected debris is then transported to the landfill or incinerated. So coming to the core screen, what we see here, where they are corrosion resistant, and they are 5 to 15 centimeters apart, and they are used to exclude the coarse materials such as logs and fishes from entering the treatment plant. And the screens are positioned at an angle of 60 degrees in order to facilitate the removing of collected material by mechanical racking. All right. So as we see here, they are core screens. There is a gap between two bars, and they are positioned in 60 degrees in order to facilitate the removal of collected material and all. So if you look into the fine screens, so these removes the material from removes the material than can be blocked pipework at the plant. So these steel bars may be spread between like 5 to 50 to 50, sorry, so 5 to 20 millimeters apart, and the variation of this fine screen is micro screen strainer consisting of an effective rotating drum of stainless steel mesh and with a very small size ranging from 15 micrometers to 64 micrometers like that. So this suspended matter as well as the large plankton can be trapped, and these trapped solids are dislodged from the fabric by high pressure water jets using clean water and carried away for disposal. So the next one is the grit removal. So grit is nothing but the trash present outside, screened outside the screen bars, and heavy wastewater with heavy or inorganic materials such as sand, gravel, and small stones that can be removed by this process. And the grit removal process such as the aerated grit chambers or vortex separator uh, or effectively settle these materials, preventing the damage and abrasion in the pumps. So the flow equalization tanks. Alright, so before going to the flow equalization, let us describe about this diagram here, which is the grit removal. And due to the gravimetric system, gravimetric settling, there is a huge amount of black dots coming. See, so these are the ones which are like grit settling at the bottom, called it as sludge as well. So that is the thing. And flow equalization is mainly to stabilize the flow pattern and composition of wastewater entering the treatment plant. By temporarily storing the incoming water in a large basics, the treatment facilitates to manage the fluctuations in volume and concentration, ensuring more efficient downstream process. So equalization tank where it allows the water to settle down, and that is how the water can be pumped up slowly. And coming to the primary treatment, where it also aims to reduce the settleable organic and inorganic solids, and primary sedimentation. So in this primary treatment, sedimentation tanks also will be there, where these tanks of wastewater will be held in for few hours, allows the heavy solids to settle down at the bottom with the lighter materials such as the oil and grease to float on the surface, and these settled solids are called as sludge, while the floating surface or floaters will be called as surface skimmers, which are used to remove the floating materials like oil and grease, and it is an essential for preventing these materials from interfering with subsequent treatment process. So as we see here, the sludge is generated, and then look here, there is a sedimentation basin kind of a thing, where huge amount of wastewater is allowed to settle in order to settle down the suspended solids as well. So coming to the key considerations of the sedimentation process, mainly to understand different types of sedimentation for its designing and operating effectiveness in water and wastewater treatment systems. And this type of sedimentation occurs depends upon the characteristics of suspended solids and concentration of the suspension. It is also important in order to understand the real world application. Sometimes the sedimentation process will exhibit the characteristics for more than one of the listed types. Alright, the design consideration of this sedimentation will be the tank shape. Either it could be rectangular or circular in shape. Inlet and outlet design in order to minimize the turbulence, sludge removal mechanisms, and detention time. So coming to the key operation and the key design and the operational phases, where the tank geometry, it can be either rectangular or circular, and inclined plate settlers, that is lamella clarifiers, which these are significantly increase the settling efficiency by providing the series of inclined plates, and this is also requires footprint of the tank, and the plate requires a large surface area for solids and to settle down at the bottom. So it has an inlet and an outlet zone, and inlet for incoming water evenly and minimizing the turbulence that could disturb the settling, and baffles are also often used in order to control the flow. And outlet zone, whether designing to design to collect, this outlet zone is mainly designed in order to collect the clarified water without disturbing the sludge. Let the sludge removal. So sludge removal can be mainly by mechanical scrapers, that is both in triangular and rectangular and circular tanks, where to move the sludge into a collection point. And coming to the hydraulic removal, where the pumps or the gravity is mainly used to remove the sludge, and the detention time could be based upon the water spent in the tank, and it is crucial for the effective settling, and it is calculated based on the water flow and the tank volume, and adequate detention time is necessary for the sufficient time for the particles to settle. Overflow rate, the rate at which the water flows over the outlet wires. This is also affecting the settling efficiency. Coming to the factors affecting the efficiency: temperature, turbulence, and particle characteristics as well. So, coming to the secondary treatment, that is the biological treatment. So, in this secondary treatment, where the principle and mechanisms involved in the biological wastewater treatment are: first one, the central role of microorganisms. Alright. So, in this biological treatment, only there is no usage of chemicals, nothing. Only microorganisms plays a major role in this. So, the biological treatment relies on the metabolic activities and the diverse community of microorganisms, and these microscopic organisms, primarily bacteria, which is also includes the fungi, microalgae, act as a natural bioreactors, and they consume these organic pollutants present in the water as a food store, converting them into energy, new biomass, energy through oxidation process, and the microorganisms obtain the energy necessary for the growth and maintenance. Coming to the new biomass, that is the cellular material, a portion of the consumed organic matter is used to synthesize the new microbial cells, which leads to the increase in the microbial population. And inorganic end products, that is organic pollutants, are likely broken down into simpler, less harmful organic substances like CO2, water, nitrates, sulfates, and phosphates, depending upon the specific condition and the nature of the pollutants. So next one is the key metabolic process, where it majorly involves the removal of organic matter by the microorganisms, which occurs through the variety of biochemical pathways such as catabolism and anabolism. And catabolism, mainly degradative process where complex organic molecules are broken down into simpler ones and releasing the energy. Okay, anabolism are the biosynthetic process which where simpler molecules are used to build the complex cellular components, leading to the microbial growth and biomass production. And the main fundamental concepts are the BOD, which is a crucial parameter in wastewater treatment, and it represents the amount of dissolved oxygen which is consumed by the microorganisms during the aerobic oxidation and biodegradable organic matter in a water sample over a period of time. All right, maybe usually for 5 days at just 20 degrees Celsius. The main goal of this biological treatment is to significantly reduce the BOD of the wastewater. All right. So there is a F by M ratio, which is like food to microorganisms ratio, and this is a critical operational parameter influencing the efficiency and the characteristics of the biological treatment process. High F by M indicates the abundance of food, that is the organic matter, relative to the microbial population, and leading to high microbial growth and lower the treatment efficiency, as the microorganisms may not fully oxidize the organic matter. And the low FIM indicates the limited food supply relatively in the microbial population, leading to a slower growth rate but potentially high treatment efficiency, as microorganisms have more time to fully degrade the available organic matter. This can lead to the endogenous respirations, where microorganisms start consuming their own cellular material for their energy. So, coming to the sludge production, So, sludge production, where the growth of microorganisms during the treatment results in the production of biological sludge, which consist of microbial biomass and other particulate matter. And managing this sludge is a significant aspect of wastewater treatment. So let us look into this aerobic and anaerobic process in the next classes, where there are several advantages and disadvantages as well. And yeah, let us look into the types, and let us look into the details of it in the next coming classes. And that's how we end it here. And yeah, that's all for today. Thank you for your time. Thank you.